Hello everyone, welcome again in Eng-Man YouTube channel. So again, we will continue our playlist of decline curve analysis and still about B factor, okay, because it's a very important and relevant topic regarding the production forecasting or decline curve analysis. All right, here we go. So in previous video, I've addressed this issue, the B factor used in decline curve analysis. Okay, but I take the information about the B factor from some other sources. And for now, I use the source, the reference from IHS, okay, which is a very reliable source. So let's take a look of what they recommend for us to use regarding the B factor in decline curve analysis. All right. So we start from exponential decline, B equals to 0, typical situations, okay, single phase liquid production under volumetric depletion. So this is the thing, if you have depletion drive, or if you have reservoir with, fluid expansion as the main drive, as the drive mechanism, B exponent will be 0, or the production will be like exponential decline. And if you have high pressure gas, high pressure reservoir, high pressure gas reservoir, it tends to have, exponential decline as well. And also tubing restricted gas production. Either you have restriction by choke, surface choke or subsurface choke, or some other restrictions in your gas production. Then basically you will have B equals to 0. And if you have water flood, but somehow it has poor performance, okay? Poor water flood performance also goes to exponential decline, unfortunately. All right, now we go to hyperbolic trend, okay? So the B factor greater than 0, but below 1, below unity. Okay, for solution gas drive, then the B factor around 0.1 to 0.4. Okay, typical gas well, okay, 0.4 to 0.5. Conventional oil reservoirs under H water drive can have B equals to 0.5. Okay, so the production will first decline and then it goes relatively constant. Okay, the curvature, the B factor plays in that position, okay, at later stage, at later time. All right. And then if you have commingled layer reservoir, and also if you have gas or water injection with relatively good performance, or very active water drive, or very strong gas cap drive, then you will have greater B factor, 0.5 and 0.4. It means your production will go for a longer period of time. Okay, your field will be even the life of your field will be even extended, will be even longer, which is good. Okay, please take note, commingled layered reservoirs, water injection, water flood, gas injection with good performance, and either water drive or gas cap drive that is quite strong. And then you will have harmonic decline, that is to say B factor equals to 1, of course. You can have this kind of performance if you have gravity drainage as your drive mechanism, as the one of the strongest drive mechanism. Or if you have high viscosity oil reservoirs under H water drive, then basically you will have harmonic production trend. Okay, so this is very practical. You can combine the B factor reference from my previous video with the one we have right here. Okay, and then yeah, basically you will decide. You will get the typical B factor and you will look at your own reservoirs. And please also note that from up there down to below, we have increasingly aggressive secondary energy sources, from only fluid expansion for B equals to 0 to strong water drive and to good performance of water flood, water injection, gas injection, strong gas cap drive. Okay, then if you have strong support either from natural water drive, gas cap drive, or artificial water flood, gas injection, water injection, then you will have more and more tendency towards hyperbolic and harmonic decline as opposed to the exponential decline. All right, so I think that's all, but at the end of the day, the best thing to determine your B factor is, of course, to do curve fitting. Just go to your production history and you select the best period of time that will represent performance of the reservoir as opposed to being influenced by operational issue. If you already select the time period and then you do curve fitting at that time period, then there you go, you will get the actual B factor. And then you compare that result with the reference we have right here. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching. See you again in the next decline curve analysis videos. Thank you.